Greetings students, today we'll be deriving the quadratic formula. We start off with the general form of the quadratic equation, or the standard form, which is in the form ax squared plus bx plus c, which is equals to 0. We are going to be using completing the square to help us derive this formula. So the first step is to divide throughout by a. This will isolate the quadratic term. So dividing by a throughout, you notice that the a that's in front of the quadratic term is reduced to 1. So we have x squared plus bx over a plus c over a, which is equal to 0 divided by a. We know that 0 divided by a, that will give you 0. So we want to move the constant, which is c over a, to the side by itself. So isolating those two, we have x squared plus b over a x, which is equals to negative c over a. So here it is positive, so once we subtract the fraction c over a to both sides, this will be a negative ca, and these two would cancel. Now the next step then is to make the side with a variable a perfect square by adding a certain time to both sides, a certain number to both sides. So we have x squared plus b over ax plus some number, and whatever we do on one side we must also do on the other side, so which is equals to minus c over a plus that number. So to calculate that number, we divide b, the middle term, b over a, by 2. So this gives us b over a divided by 2, which is since we're dividing by 2 is the same as multiplying by 1/2. So b over a times 1/2, which is equals to b over 2a. So the next step then that we're going to do is to square this value. So b over 2a squared, which will be the same as b over 2a times b over 2a, is equal to b squared over 4a squared. Now this term we're going to introduce into this expression here that we have in the bracket, so that's going to replace those brackets. So we have x squared plus b over ax plus the term that we just introduced, this term here, which is b squared over 4a squared, which is equal to negative c plus b squared over 4a squared. Now because we have completed the square here, we know that this is a perfect square. So therefore that will give rise to, when you factorize it, x plus b over 2a quantity squared, which is equals to, now we simplify this and have the b squared term first, because this is positive, and we add these two, the highest the lowest common multiple will be of these two will be 4a squared. So we have b squared minus 4ac divided by 4a squared. So once we have added these two, now the next step then is to take the square root to both sides. So taking the square root to both sides, then we'll isolate this term here, these two would cancel out. So we have x taking the square root to both sides. That will give me x plus b over 2a plus or minus the square root of b squared minus 4ac all divided by 4a squared. Now here, whenever according to the rules of indices, if I take the square root of a numerator, I must also take the square root to the denominator. So doing that then, I will have x plus b or minus b over 2a, x is equal to negative b over 2a plus or minus the expression b squared minus 4ac. Now the square root of 4a squared, the square root of 4, which is equal to 2, and the square root of a squared, which is simply a. So that gives rise to 2a. And you notice here on the right hand side, I have a fraction, two fractions that have the same denominator. So to add them together, this will give me x then is equals to keep one denominator, this will be x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. this expression here, or this equation here, is referred to the quadratic formula. So this gives rise to what is referred to as the quadratic formula. So thank you for watching.